external parameters, and we compare them. If the leading parameter is large, the corresponding binary describer will be set to 1. For example, the first pair of the LBD, the I first and the I second. If the I second is bigger than the I first, the corresponding binary describer will set to 1. As we selected 256 pair of live LBD, so we will get 2056 binary describers, and we will calculate the distance by using the Hamming distance.
Okay, thank you. My name is Hanafi. Right now we see from Youngmin. This is UIC, ASEAN, the second ASEAN poster presentation. Maybe this is the last of presenter. Let's we see together.
Segments that detect in the frame are small, and each time both the LBD method and our binary describers may cost almost the same time. But in other terms, like this way and this part, there are more members of segment detected in the frame, and you can see the LBD may cost much more time than our method. And we also calculate the average time of our method. Compared to the LBD method, we can see the LBD method costs about this time, and our binary describer costs this time. And we can see that the speed of the binary describers is increased by about 20%, and the matching result is shown in the figure 9. You can see the matching is pretty good. But finally, in the conclusions, we propose a rigorous SLAM method which combining the point and lines, and we reduced the fragmentation problem, and we also simplify the line describers and speed up the time of the matching. And in the future, we are going to try to finish the point and line based the camera pose estimation method by this year. We actually done about 50-60% of this, and then we will update all this information in the map and drawing the map. Okay, thank you very much.
Okay, thank you very much for the presentations.
Thank you.
Maybe because the time is running out, sorry. So if you have any
yes,
questions,
the time is out right now, sorry.
Chat with Zoom. And we can move now to the final presentations of these sessions. Classifications of highly correlated ASL gesture for you with the sign language recognition system. These presentations.
I think nobody asked the question for him.
Mr. Jeremy, can you answer this year? Yeah.
Okay, thank you.
Thank you very much. Mr. Sunusi Abdullahi or Professor Fosi?
Okay, maybe this is the last of presenter. Let's see her together.
Sanusi. Hi, Sanusi.
Whoa, Professor Cousin.
Okay.
Professor Cousin. He is a speaker in the 7th UIC seminar before. Okay, my name is Hanafi.
So if you're ready, you can start. So this is the final presentations.
The classification of highly correlated ASL gesture for ubiquitous sign language recognition system. Sanusi Bala Abdullahi and Professor Dr. Kelsin Kemuntai.
Sanusi, please open microphone.
Okay, this is so interesting.
Yes, can you hear me now?
Okay.
Yes,
I am Hanafi. Let's we see together.
Good evening, all. Please, my name is Sanusi Bala Abdullahi from Computer Engineering Department in Mongoose University of Technology, Tamburi. It is my pleasure to present before you my poster presentation titled Classifications of Highly Correlated American Sign Language Gestures for Ubiquitous Sign Language Recognition System. So, These are my presentation outlines. These are my presentation outlines. This paper tried to try to bring some novelty in the sign language translation system. As we know that sign language is a natural communication language which involves use of hands and sometimes body motion to inscribe the gesture or to perform a gesture. So the sign language actually is a language which is adopted by the hearing disabled persons, or that is the people we used to call deaf. That is, the sign language is normally adopted by the deaf people or people with hearing impairment. So these people with hearing impairment actually were born from the family of normal hearing people. Most of the deaf people are born from the normal hearing people. So it is very difficult for the parent of those disabled persons to communicate with their children, and also sometimes it is very difficult for the normal hearing people to listen and to communicate with deaf people, that is the hearing disabled persons. As we can see, this is the picture of this is the hearing impaired persons, that is the deaf, and this is the listener. They are trying to communicate. So the communication between these two parties, that is two community, that is the normal hearing people and hearing disabled persons, can only be possible by sign language. As we mentioned, that sign language is a natural communication language which involves use of both hands and sometimes motion of the body to translate or to interpret or present your instinct, your explanation or your expression. So we can see based on this, we have a number of more than 400 million sign language speakers in the world. That is the native speakers of sign language. We can see based on the population across the world. So this sign language actually has many forms. As we explained here, we have many types of sign languages in the world adopted by different countries, but most of the sign languages were incepted, that is originated from American Sign Language. So American Sign Language is one of the native and famous sign language with over 500,000 speakers, and most of these speakers were resided in the United States of America. So what brings this issue of to make a contribution, the technology to develop a system for the sign language? Why? Because the sign language is a communication language used by the deaf persons, and deaf persons are human like us. They need to satisfy their basic needs of life. As we can see, the deaf, they need to acquire knowledge, they need to acquire education, and they need to engage into businesses, and they need to participate in sport, entertainment, and sometimes the deaf people, they used to communicate during traveling. Like if they are inside vehicle, like inside the bus, as we can see in the picture, the deaf people, they used to communicate with normal hearing people during the travel or during the walking, and sometimes in some places. But this is what brings the issue of we have to develop a system that can facilitate the communication between the deaf people and the normal hearing people, because the sign language as a natural language has a very complex grammatical structure which is very difficult for the normal hearing people to understand. So this sign language as well is also very we have a few number of people that can try to a few number of professional speakers that try to explain or to interpret and train the normal people to learn the sign language translation system. So due to this problem, the issue of having ineffective translation system between the deaf community and normal hearing people used to bring the issue of social isolation. It used to bring an issue of isolation and discrimination to the deaf people. So the deaf people cannot have a rest of mind to speak, to talk, and to interact with the real world because of the lack of effective translation system. So we can see, as reported by World Health Organization, we used to, because of this unaddressed ineffective translation systems, every year the world is losing around 750 billion US dollars, as reported by World Health Organization, in the process of addressing the issue of social isolation, which normally used to bring the issue of mental illness and the mental retardation by the deaf people. So based on this, efforts have been made by many researchers to see that they contributed in trying to develop a system that can give an effective translation and the communication system between the normal hearing people and these people with hearing disability. These are some of the existing methods, and these are what the existing method tried to solve. As we can see that in LIM et al. 2019 tried to develop a system using deep learning. The system is using convolutional neural network, try to extract some features from the hand images. That is what they call hand energy information. So these hand energy information features were extracted and trained using convolutional neural network, and developed this model as the model that tried to classify those gestures. So the next one is the Lee et al. 2020 try to solve also an issue of this translation of sign language. So this system also used convolutional neural networks, and also develop some features where they consider the hands and the body motion of the signer as a convolutional graph. So this convolutional graph, they consider the body of the human as some part of the body as the edges and the vertices of the graph, and they train the convolutional neural network. Then there is also another work at Rasgul et al. 2020 that developed the same deep learning network, but they used multimodality sensing information, where he fused the two sensing modality, the RGB camera and the depth sensor, to extract features from the hand of the deaf and also some part of the body of the deaf. But according to our observation, this method actually lacks some dimensionality, and the information taken by this method cannot give the full representation of the gesture, because most of the gestures, especially the American Sign Language gestures, are performed using hands, not body motion. So based on this, we try to develop a system, as reported by others, as I explained, that there should be some misclassification issues, and the method get this misclassification due to the lack of dimensionality of the features they extracted, and as well they reported similarity issues. So we try to develop a system that try to solve the issue of similarity. This system try to choose very highly correlated American Sign Language gestures that have an opposite meaning, not just like in the previous method where they just selected the data and trained and extracted features, but most of those features are not enough to give a representation of the gesture. And as well, some correlated words like this ones we selected has significant impact and pose a critical challenge to the translation of the gesture, because sometimes if the signer try to sign a word money, and then the translation algorithm, if it is not well coded, will try to translate the word gesture money to jump. It will misinterpret the word. So sometimes this used to make the listener to feel offended, because the signer is trying to tell him this is money, but he will just see the translation as a jump. Like in the second frame, we can see that the signer is trying to translate, to sign the word happy, but the classification algorithm misclassified the words as sad. So these problems actually need a very an urgent and special intervention, so that we can allow the deaf to participate in our real world environment. So this is the concept of our method. We can see that we extracted features from the hand joints. That is, we use the fingertips of two hands, because most of the American Sign Language gestures are using two hands. So we extracted 168 features from these two hands, where we have 5 fingers on the hand. So the 5 fingers, we used the first from pinky to middle to the index. The pinky and the index have five joints